This is video lecture number 5. It's composed of 3 parts. The first part is acid-base indicators. We're going to look at table M, and we see table M is a little difficult to understand, but it tells us the range for a solution, pH, based on what color an indicator is in that solution. So if we have a solution and we add methyl orange and it turns yellow, then the pH of that solution is greater than 4.4. If we have a solution in which we put litmus and the litmus turns red, then the pH of that solution is less than 5.5. So by using these two indicators, we can see that the pH of that particular solution is above 4.4 but under 5.5. And this week's lab deals with using indicators to determine the pH of different solutions. The second part of today's lecture deals with reactions between acids and bases. We talked about this in last week's lab. When an acid reacts with a base, it will produce salt and water. A salt is an ionic compound composed of a metal and a nonmetal, or a metal and a polyatomic ion. So if we take HCl and we react it with NaOH, a double replacement reaction happens. We form NaCl and HOH. We still have to balance, but this one is already balanced out. Another acid is nitric acid, HNO3. If that reacts with potassium hydroxide, then a double replacement reaction will happen. We form KNO3 and once again HOH. So KNO3 is a salt. It's a metal and a polyatomic ion. Again, we would balance, but it already is. And we're going to find they get tougher than this. One last one, if we take sulfuric acid and we react it with calcium hydroxide, double replacement reaction, calcium sulfate. Calcium is +2, sulfate is -2, and once again water. This time the equation is not balanced. We have 2 OHs on the left, we put a 2 in front, and that takes care of everything. The third concept for today is actually a mathematical equation that deals with titration. Titration will be our lab next week, and it deals with finding the molarity of an unknown acid or base. It deals with the concept of neutralization that occurs when we add an acid to a base. We form salt and water, which will be neutral. The equation is written as follows. It's pretty self-explanatory. A is for acid, B is for base, V is for volume, M is for molarity, OH is the number of OHs in the base, and HA is the number of H's in the acid. We're going to attempt a problem at this point. So you need to open up the worksheet, packet, and open up to the titration and neutralization worksheet. So if you open to this page, the first part we're going to do in class. So we are basically looking at the titration problems. We have a formula, HA MAVA equals OHB MB VB. We're going to use this as our basic formula. We are going to follow ESA, equation substitution answer, but let's go ahead and start with the substitution for number 1. HA is the number of H's in the acid. So in HCl, there is 1 H. Ma is the molarity of the acid, 0.050 molar. And Va is the volume of the acid, 50.0 milliliters. Equals OHB, how many OHs are in NaOH? And that is 1. The molarity of the base is what we're solving for. And the volume of the base is 100 milliliters. So now on your calculator, we solve for MB. So 1 times 0.05 times 50 divided by 100. Make sure you do it. But the answer is 0.025 molar. And we'll discuss in lab how these types of problems are solved in finding the information like volume. So I could do another one, but I think we'll just wait for class. So that takes care of video lecture number 5, which, believe it or not, is the last video for acids and bases in terms of my lectures.